Yeah, so good evening, everyone. So in the last video, we are talking about sir, uh, decimal to decimal number to binary conversion. Okay, so in these, so we got the program successfully, but we are unable to trace the problem. Okay, we are unable to trace this algorithm. So don't worry. In today's session, we are going to explore how this algorithm is going to work. Okay, it is easy only, just one small step, so we didn't include it. That is the problem. Okay, now, so listen carefully. Sir, here I am going to take one stack. So here stack importance is very important in this algorithm, sir. Stack usage is very important. Listen carefully. Listen carefully. Okay, now, sir, first time, what will happen? Consider the value of n which I have given is something like we will take 8 first. Okay, let us consider the value of n is equal to 8. This is the input what I have given. Okay, sir, please ask these administrative works at the end of the session. Okay, so generally at very beginning, don't ask running notes related activities, WhatsApp group related activities. So after completion of the session, I will give time, I will spend time. There you can ask all your queries. Okay. So while the session is going on, please don't do these activities. Definitely, I will do that. Okay. Don't worry. Right. Prashant, definitely you will get it. Okay. Right. So n is equal to 8. What is the first condition we have? So n is equal to 8 or not, we are checking. Sir, is the value of n is equal to 8? Sorry, n is equal to 0. No, it is not 0. So we are going to return 0. No. So else the condition is fail. N percentage 2. That means what? 8 percentage 2. Sir, if you calculate 8 percentage 2, what is the remainder that we are getting? Sir, is 8 is divisible by 2 or not? Yes, 2 fours are 8. Remainder will become 0. That 0 is pushed into the stack for future use. Remember this word carefully. 0 is pushed into the stack. Next, sir, 10 into convert of n by 2. Sir, keep this in mind. 10 into is the operation which is there here. Okay, so convert of n by 10. We are going to call this one more time recursively. Sir, now what will be the value of n? Sir, 8 by 2 means we will get 4. Sir, again, is 4 is equal to 0? No, n percentage 10. That means 4 percentage 2. Sir, 4 percentage 2 is also 0, right? That 0 will be pushed into the stack. And sir, one more operation is pending. What is that operation, sir? 10, right? That multiplication we will do later. Sir, again it is going to call the same algorithm. Previously, the value of n by 2 is 4. Now n by 2 is nothing but 2. Okay. Now n by 2 is nothing but 2. Sir, now the latest value of n will become 2. Sir, is 2 percentage 2 is equal to 0 or not? Yes. So that means what? Again that 0 will be pushed. Okay. So 2 percentage 2 is 0. Again that 0 will be pushed. Sir, what about the remaining operation? 10 into. Now, sir, it is going to call for what is the next value of n? Your n will become 1. Because if you take, sir, 2 percentage 2, sir, 2 ones are 2, remainder is 0, but coefficient is 1. That's why 1. Sir, is it equal to 0? No. Then, so n percentage 10. What will be the value of n? Sir, 1 only, right? So 1 percentage 2 is equal to 1. Okay, that 1 will be pushed into the stack. So then that 10 operation is also there. So next time, what is the value of n, sir? Is n is equal to 0 or not? Yes, only 0. So return 0. Listen carefully. Here, for performing popping operation, we have to use a plus symbol, and for reusing these values, we have to use multiplication operation, because for this result, we have one operator is there. For getting the total result, we have one operator is there. That means these values are pushed into the stack. That's why we have to use a plus operator while doing popping operation. But whatever result you got, you have to multiply with 10, because this 10 is multiplied every time in the stack entry. So how it is going to be extracted and how it is going to be multiplied, I will explain with the help of clear diagram. So up to this, do you have any doubts? Can you please confirm? Up to this, do you have any doubts? Please confirm. Because if it is clear, we can go with the next step. Okay. Yeah, I will take another number example. Vishal, don't worry. Right. Sir, now what is the next operation that we are going to have here? Sir, we have to pop the data. Okay. We have to pop the data. Sir, what is the first value? 0. Okay. What is the first value? Observe my calculation. So the first value is nothing but 0. What we have popped. 0 plus. Sir, what is the next value? 0 completed. What is the next value? 1. Sir, while popping 1, you have to multiply with 10 because that operation is also included here. So now 1 into 10. The result will become what, sir? 0 plus, sir, 10, which is nothing but 10. Observe carefully. Okay. Now, sir, what is the next one? No. 1 minute. 1 minute. Yeah. Sir, what is the result that we got? 10. Sir, next time, next pop operation we have to do, right? What is the next pop operation? Sir, 0. 0 plus, okay, 0 plus. Sir, what is the previous result that we have? What is the previous result that we have? 10. So that 10 into, again you have to multiply with 10. Sir, what will be your result? So 10 plus 100. Okay. Sir, your result will become 100. Right. Sir, what is the next operation? Again, next time we have to pop. Sir, next time the result is 0. 0 plus. So what will be the next value? Sir, already 100 is there. 100 into 10. Okay. Which will become 1000. Sir, the result is nothing but 1000. Okay. Right. Like this. Sir, now I think somewhere we have done extra. Any calculation mistake? 1 into 10. So it became 10. Anywhere calculation mistake? So 1 into 10 we got correctly. So 10 into 10 we got 100. So 100 into 10. Hmm, Actually here itself the result we are getting, but actually one more iteration is there. 0 plus 0 plus. So 1 into, just a minute, we will trace back again. Sorry, just a minute, we will trace back again. So otherwise we will take another number so that we can get clarity. Yeah. So now I will take n as something like, let me take a 12. Sir, what is the binary equivalent for this 12? I think 8421, right? Yes, this is the equivalent. So here my stack is there. Okay, here my stack is there. Yeah. Now observe carefully, sir, how it is going to work. So follow the step-by-step calculation. So first n is equal to 0. No Sir, n percentage 2. N percentage 2 means, sir, if you divide 12 percentage 2, what remainder we are going to get? 0, right? So 12 percentage 2. The remainder is nothing but 0. Okay. So that 0 will be pushed into the stack. Okay, right. Sir, what is the next n value? Your n value will become. So if you divide 12, so with 2, sir, 2 6 are 12, right? So remainder is 0 and coefficient what we got is 6. So now n value will become 6. Is it equal to 0? No. Sir, again n percentage 2. That means 6 percentage 2 is equal to. What is the 6 percentage 2? If you divide 2 with 6, 2 3s are 6. Remainder is nothing but 0. Sir, again we got one more 0. Okay, right. So 6 percentage is 0. Next time the value of n will become 3, sir. Okay. Next time the value of n will become 3. Sir, is it equal to 0? No. Again, so 3 percentage 2 we have to calculate. So if you divide with 3 with 2, sir, 2 ones are 2. The remainder is 1. Sir, we have to store that remainder here. So which will become 1. Okay. Next n value will become 1. So 1 I am dividing with 2. Sir, it is 2 zeros 0. Remainder is nothing but 1. We are pushing that remainder. So next n value will become 0. Just it is going to return 0. But where this 10 will be available? This 10 is available for every entry except 0. Because for 0, we are not taking this. So I think this is clear up to this, whatever we discussed. Now, here observe carefully. First we have to pop one value. This 0 will be popped. Okay, this 0 will be popped. And which operation we are using here? Plus operation. Sir, now this 0 will be popped. Sir, 0 plus 0 plus. So 10 into, sir, next last call of this one. Last call of this convert. What value it returned, sir? This value only, right? Last value of this one is nothing but, so this value. Now, sir, it is going to return. Okay, it is going to return which value? 1. It is going to return which value? 1. So that 1 into, to which value we have to multiply? 10. Sir, your result will become 10. Okay. Pradeep, 10 power 0? No, I think so. 10 power 0? No, 1 into 10 only. 10 into 0. Ah, yes, 0 into 1. See, because on the last call of convert n by 2, results this value only, right? We need to multiply this value with this value, and result we have to combine with 0. No, no, no. Sir, this call is different. This value, whatever we got, is different because on the last call, this one is executed. It is simply returning 0, not multiplied with any number. That's why I have kept empty here. Yes, what is the returned value? 0. 0. 0 plus, what is the next next trace? The next popped value is nothing but 1. 1 into 10 will become 10. Correct only, right? No, no, no. Yes, yes, correct. 1 plus 0 into 10. Correct, right? Yeah, Pradeep.
Yeah, I was saying the return value is 0, but it is actually a method call that is happening, and it will be 10 into 0 because return value is 0. Right? So that extra will not come. We were getting that extra, but that will not come. Because if we get 10 here only, then again it will be a problem.
Correct, correct. Here we have to get
0. Because 10 into convert of n by 2, right? So which is 0. So 10 into return value is 0. So 10 into 0. So 0, 10 by 2 is already 0 and return value 10 into 0.
So 10
so
into 0, it will become 0.
Yes.
Okay. 0 is added to which value?
For the next, when we pop up for the next time, then we will add again 0 plus 1 into 10. 10 into
Yeah, maybe 1 into 10. Okay, we will see that approach. 1 minute. Let us go with that. So first approach, so 0 into, okay, so 0 into 10, so which will become 0. So next time 0 plus 1 into 10, correct, right?
Yes, sir.
It will become 10. Okay, it will become 10. So next time 10 plus, okay, so what is the next popped value?
10 into
No,
1.
it is
10 into 10 into 1.
yeah, 10 into yeah, 10 into 10. Here we are going to get 1 because that stack entry, right? So it will become 1 plus 100.
Hello, sir.
No, I think
Sir,
it is wrong.
sir, should I say something?
Yeah, yeah.
Sir, actually the return value is 0.
Hmm.
So 0 will be returned into, that will be multiplied with 10 according to the formula.
Hmm.
And 1 and the stack comes to the previous stack, right?
Hmm.
So the previous value is 1, so 1 will be added.
Hmm.
So it will become 1 plus 0 into 10 will be 0, that is 1.
Hmm.
Again, so
1
1
minute,
will
1
be
minute. I think that
one.
was we are doing in the previous case, right?
Sir, that is the only that will happen only, sir.
Just because of some confusion. Okay, don't worry. We will see now. Just a minute. So
Hello, sir.
yeah.
Sir, do we are adding this return 0 into the stack or not, first of all? I
Return
don't.
0 will be pushed into the stack definitely. So because how the values are going to be popped in the sense from the stack only. See, first time this value will be pushed into the stack. That is nothing but 0. Next time this value will be pushed into the stack. Next time this value will be pushed. So next time this value will be pushed. So after completion of all the conditions, whatever base value is going to be returned, that also will be pushed into the stack. Compulsory this is. So whatever values are there here, what is a last call? That is very, very important here. So whatever last call we are getting, based on that we have to trace. I think we, if you ignore this 0, rest of the things will become smooth. Let me check. So whatever value that we got here, 1, right? 1 plus what is the returned value? So 1 into what is the value that we have got here? 10. So 1 into 1 plus 10, which will become no. Here we have to get again we are getting confusion here.
Sir,
Someway
1
it
plus
has to
0
return
into 10.
10 only.
So 1 plus 0 into 10.
1 plus 0 into
10. That is 0 is the return value, and 10 is multiplied with the return value. So return value will be returned to the previous call. That is previous call is convert n
so
by 2.
0, 1 minute, sir. 1 into 0 into 10 will become 1. So next time the result is 1. So 1 plus, so 1 into 10, right? So here it will become 1 plus 10. So we are getting 11, correct, right? So
Yes, sir. Yes,
next
sir.
time the returned value is 0. 11 plus
No, sir. 0 plus 11 into 10.
yes, correct. 0 plus, because these are the returned values. 0 plus, so what is the previous value that we got? 11 into 10. So which will become 0 plus 110, which is nothing but 110. So next last time the popped value is nothing but 0. So 0 plus 110 into 10. So which will become 1100. So this is our result. Okay. Sir, have you observed this 0 is nothing but this first 0. And this 0 is nothing but a second popped 0. And this 1 is nothing but this value. And this 1 is nothing but the returned value. I think for the previous also 0 plus we can take. Even if you take 0 plus anything, it will become that value only. And whatever returned value we have here, so that we are multiplying with 10. Whatever return value that we have, that we multiplied with 10. So whatever return value that we have, I mean whatever value which is returned, that we are multiplying. Whatever returned value is there, that we are multiplying. Whatever returned value is there, that we are multiplying. Like this we are getting. So I think somewhat with the confusion, we got the clarity. Yeah, correct. Yeah, don't worry. I will take one more example and we will trace it. Don't worry. Yeah. So someone is posted this one. Okay. So here is the calculations. Okay. So this is for which number? Example. Example, I can say n is equal to 12. For this is nothing but example what we have. Okay. Suppose if you take n is equal to, yeah, we will take any other value. Maybe let us take 8. Okay. We will see how it is going to work. Just a minute. I will save this. This is a problem number. Yes, 10. This is nothing but a problem number 10. Sir, what is the file name that I have given? So recursion problem number 10_1. Right. Sir, now again I am taking the same problem. Okay. So with one more example, I will take. So now let us take n is equal to any other values. Let us take n is equal to, sir, something like so 15 we will take. Sir, what is the binary equivalent for this? So 8 4. Okay, 8 4, and then we are going to get 2 1, right? 8 4 12. No. I think you are going to get all ones, right? 8 plus 4 12 13 14 15, all ones, right? Yes, let me try this. Okay, sir, here we have a stack is there. Okay, we have stack is there. So n percentage 2. So I am dividing, sir, 15. Okay, I am dividing, sir, 15 with 2. Sir, 2 sevens are 14, remainder is 1. So push that remainder. The next n value is 7. Again divide with 2. Sir, 2 threes are 6, remainder is 1. Sir, push that remainder. So again we are going to divide. Sir, 2 ones are 2. So the remainder is nothing but 1. So it is going to be pushed like this. And the last time the value of n is equal to 0, because after this calculation the value of n will become 0. If n is returning 0, then it is going to return the value 0. And here we have some special operators like, so 10 10 10, like this we have. Okay, so like this we have. Sir, can you please tell me, sir, what is the first value that we have? 1, right? So we need to take so 1 plus. Okay, 1 plus. So which value is returned here? 0. Sir, 0 into 10, correct, right? Is it correct? Yes, please confirm. Is it correct? So now it is. So now it is going to return. So 1 plus 0, which is nothing but 1. So this is the latest value. Sir, next, what is the popped item? So next popped item is nothing but 1. I mean, this one only we have taken. Now next popped item is nothing but 1. Sir, 1 plus, what is the previous value that we got? 1. Sir, 1 into 10. Sir, what will be the result? So 1 plus 10, which will become 11. Okay, sir, next, what is the next value? 1. 1 plus already 11 is there, last time calculated value. So 11 into 10. So now what will be the answer? So 110, which will become 111. So next, last item is nothing but 1. So 1 plus last calculated value is nothing but 111 multiplied with 10, which will become 1 plus 1110. Sir, your result will become 4 ones. So this is nothing but what we have here. Okay, just confusion, that's all, because we are perfect with algorithm and it is working perfectly. Just at the time of tracing, we are getting confusion. Beyond that, nothing is there. Sir, yes, 0 is the popped first. 0 plus anything will become 0. That's why I'm not considering this, because we are getting confusion. Sir, clear up to this? Please confirm. Yes. Practice by taking a few more examples on the paper and pen. Yes. So recursion 10_2. Sir, we have another approach is also there for this, but it will work or not, I don't know. But let me check. Okay, another version is there. Okay, let me check whether it is working or not. So version 2, if it is not working, we will ignore that. Okay, so what is that another version here we have? So same program like previous program, only I'm taking. Okay, the simple modification here is nothing but static. So I'm taking void convert. Okay, void convert of n. So if n is equal to 0, sir, simply I'm going to print system.out.println or print of, sir, I will print 0. Okay, I will print 0 and return. That's a return is not required, I think so, because we have taken 0, right? So otherwise, sir, what I am going to do is, sir, I'm going to call. Okay, I'm going to call. So convert of n by 2, next number, something like a digits calculation we have done, right? In the same way, sir, after this, so system.out.println, sorry, system.out.print of, I'm taking n percentage. Okay, sir, we are capturing the reminder. Yeah, we can store. If you store it in a variable, it will become some other big task. That's why directly I'm printing. Okay, sir, is it possible or not? Yes, let me check how it is going to work. So I'm going to compile the program. Some ways. Yeah, so we have taken directly. So there is no return type. It is not recursion. Why? Have you not seen here? It is calling a function by itself. Okay, let us check whether it is going to work or not, because a small thought I got. Is it working? Is it correct? 8421 code. Sir, if I am giving 15, 8, 1 extra 0 we are getting, no problem, no problem. So if you want, you can remove this. So even if you want, you can remove this, nothing will happen. No, compulsory we have to print at least something. Let me give you an empty space. Now is it coming 15? Correct only, right? If I'm giving 16, okay, so if I'm giving 5, yes. So like this also we can do, sir, a simple approach. So here, instead of storing in the stack trace and formula, okay, if any, yeah, that's what. Okay, we can do like this. Okay, this is nothing but what is the another version that we have for this. Okay, so we can simplify this function also. Okay, Kasiredi is telling, sir, we can simplify this logic. Sir, how you can able to simplify this logic? Very simple. Sir, if n value is not equal to 0, then do this operation. Okay, if n value is not equal to 0, do this operation. That's all. Simply it is going to work. Sir, please confirm with somewhat confusion. successfully we completed decimal to binary conversion by using recursion. How many possible ways are there also we have seen. Clear, right? Everyone, please confirm. Clear, right? Right. Right. So the next program related to this recursion, 11th program. Sir, what is the program that we are going to discuss here is, sir, I think you know about this. We have discussed several times about this. Implement a program, okay, sir, to find nth Fibonacci number. Okay, so we have to implement a program to find nth Fibonacci number. Okay, sir, now I have a doubt. So in the Fibonacci, already we have seen what is the first number? 0. Second number 1. Sir, what will be the third number? Yes, very good. 0 plus 1, which will become 1. What is the next number? 2. What is the next number? 3. What is the next number? 5. Sir, and so on, right? Okay. Sir, now, sir, f of n, okay, f of n is equal to, we will get some value when, if n is equal, okay, if n is equal to 0 or n is equal to 1. That part I will explain later. And f is equal to, sir, other than this. Otherwise, we are going to get n value. That is n, if n is greater than 1. Sir, I will replace this function. Can you replace this second function? Think a bit logically. I will give 2 minutes time. So try to replace this function according to the formula. Yes. Think a bit logically and tell me. Right. Sir, here, sir, if x is replaced with, yeah, good, correct, Safi. F of n minus 1 plus f of n minus 2. Like this we can take. That means previous number, previous to previous number. Sir, is it correct? Please confirm, everyone. Is it correct? Right, sir. So now let us go with the next one. Okay, let us go with the implementation. Sir, if n is equal to 0 or fn is equal to 1, we are going to return n. We are going to return n value, not 1. N is equal to 1. Whatever value is there, that value. If n is equal to 0, it will return 0. If n is equal to 1, it will return 1. Because 0th term is 0, first term is 1. Like that we can treat. So don't worry, I will take example and I will explain. Sir, I want to find out the first term. Okay, I want to find out the first term. Sir, according to this formula, if n is equal to 1, we have to return 1 or not? Yes. Sir, I want to find out f of 2. Sir, second term I want to find out. What is the formula for finding second term? This is the formula. N minus 1. N is replaced with, sir, n is replaced with Sir, what is the f of 2 minus 1, which is nothing but 1, plus f of 2 minus 2 is nothing but 0. Sir, f of 1 value just now we calculated. F of 0, sir, 0th term. What is the f of 0, sir? Not 1, Chaitanya, why you are telling 1? So f of 0, if n is equal to 0, it will substitute 0 only. Okay. So now we are going to get the value 1. Sir, is f of second term, is it 1 or not? Yes. Sir, I want to calculate f of 3. What is the formula? F of 3 minus 1. Sir, plus f of 3 minus 2. Sir, what is the 3 minus 1? Sir, 3 minus 1 will become f of 2, plus f of 3 minus 2 will become f of 1. Sir, what is the f of 2 value? Just now we calculated, it is nothing but 1. Okay, f of 2 value, and f of 1 is nothing but 1. So that the third term what we have here is 2. Okay. Now, sir, f of 4 I am taking. Sir, f of, so what will be the value? 4 minus 1. So plus f of 4 minus 2. Okay. Sir, f of already, sir, 4 minus 1 we calculated, which will become 3, plus f of 4 minus 2 we calculated, which will become 2. Sir, f of 3 value is what? F of 3 value is 2, plus f of 2 value is what? F of 2 value just now we calculated, it is nothing but 1. The result will become 3. Sir, and so on. Okay, and so on. Sir, what is the f of n? How you can calculate? Sir, f of n minus 1 plus f of n minus 2. That's all. So this is the algorithm what we are going to follow for calculating Fibonacci. Sir, we can't able to generate the sequence. We can able to generate only nth number. If you want a sequence, you have to write it in our main program to get this, to capture this sequence. Or in our previous examples, we have seen, we have taken one array list. In that array list, we pushed all the values. Okay, like that we have to implement. We don't have any other alternative ways. Okay, sir, anyway, how to print this nth term, how to find out, and how you can able to generate with the sequence, I will explain. Can you please confirm, is this algorithm is clear for you people? I mean logic. Right. So let us take an example program. Yeah, I will show you. Don't worry. Yes. So static integer. Sir, what is the function that we have? FIB. Okay, so FIB of, okay, FIB of integer n we have here. So if the value of n is equal to 0, or if the value of n is equal to 1, then it is going to return the value of n. Otherwise it is going to return, so FIB of, it is going to return, sir, FIB of what value it is going to return? Sir, n minus 1 plus FIB of n minus 2. Like this we have. Sir, now I am going to read the value of n. Sir, here for my convenient purpose, I am taking a for loop. Okay, I am taking a for loop where I value is going to start from 0, I less than or equal to 5, I plus plus. So system dot out dot print. Okay, system dot out dot println of, sorry, print of. So demo dot FIB of, I want 0, sorry, ith number like this, and followed by some space or comma followed by space I am giving. Like this we have. So let us run this code. Is it going to generate Fibonacci sequence? Sir, up to, so if I am giving 5, sir, 5 values, is it working properly or not? Yes, I have given. So n value, I think here we can reduce like this. Okay, now let me compile. Sir, I want first 5 numbers. Is it coming or not? Yes. Sir, I want first 10 numbers. Is it coming or not? Yes. Like this we have. Just a minute. right? So like this, it is going to generate the sequence. So I think the program is clear for you, but let me check how it is going to work. Sir, here you people are going to get a somewhat a confusion. The problem here is in the stack, multiple entries will be there. Okay, in the stack, multiple entries will be there, but let me filter. Okay, let me filter and we will trace out. Okay. Yeah, program is to find nth Fibonacci, correct. Okay, like, sir, first I will show you theoretically how it is going to work. Then we will go with the practical. So I think better already we calculated. So better I will copy paste that. Right, this is the calculations. So what we have done just before. Okay, now, sir, we will take sir Kasireddy sir, please check the main method. So I have written the program only to generate nth Fibonacci, but here I have written that function call inside a loop. So loop, how many times it is working, those many times it will call. If the loop is dropping 0, it will return 0th Fibonacci number. Okay, if it is returning 1, so then first Fibonacci number. Like this we are going to get. I informed this already. Okay, right. Sir, let us see what will happen. So first of all, I don't want to take a stack here. So how internally it is going to work at top level, I will explain. So first Fibonacci of 4 we are taking. Okay, sir, what it is going to do? It will call in two ways. Sir, what is the first one? Sir, f of so n minus 1. That means 4 minus 1, which will become 3. Then, sir, it is going to call f of 4 minus 2, which will become 2. Sir, since it is not returning any value, in the stack entries won't be there. So because it is again calling, okay, it is again calling whatever value returned by f of 3, that will be pushed into the stack. Sir, when you call f is equal to 3, again it will call f of 3 minus 1. So which 3 minus 1, which will become 2. Sir, 3 minus 2, which will become 1. Sir, f of 2, again it is going to be called with, so 2 minus 1, which will become 1. 2 minus 2, which will become 0. Sir, then again this f of 2 is going to be called for f of 2 minus 1, 1, f of 2 minus 2, 0. Like this we have. Now observe carefully. When n is equal to 1, it is returning n. That means 1. That value will be pushed, sir. Don't ask where it is going to be pushed. Somewhere it will be pushed in the stack. Okay. Exactly the paths we can't able to find out. Then f of 0. If n is equal to 0, that 0 will be pushed into the stack. Sir, then f of 1. 1 means it will be taken 1. So f of 1. Sir, it will be taken 1. So f of 0, it will be taken 0. Okay, like this. Sir, which operator we are using here? Plus, right? So we are going to perform all these operations by popping. So 0 plus 1 plus, so 1 plus 0 plus 1. The result will become 3. Sir, is it correct or not? Right. So if you want a full-fledged clarity, listen carefully, friends. Sir, I am calling FIB of 4. So it is calling f of 3. Again, it is calling f of, forget about f of 3, f of 2. So if I call f of 3, again it is calling f of, and f of 1. Forget about f of 1. So f of 2, again it is calling f of 1. Whatever returned value is there, that will be captured. Again, revert back. Sir, it is calling f of 0. Whatever value returned, that will be stored. Sir, again revert back. It is calling f of 1. So that f of 1 result will be stored. Again, it is revert back. Again, it is revert back. Sir, f of 2. Sir, f of 1. So what is the result value? 1. Sir, again revert back. Again come here, f of 0. Like this, we are going to store. So this is the way how functions calls is going to be happen. Okay. So since we don't have any value here, that we can't represent here. Okay, sir, please confirm, is it clear up to this how this algorithm is working? Vishal, can you please confirm, especially for you? Clear up to this? No, it is just for our understanding purpose. I have written in the form of tree. Okay. Ajit, as usual, it is started at 8:15. But max time we have taken for that. Again, today we got some confusion in that algorithm. Finally, we traced it. Cross-check the video. Okay. Right. So I think this one is 11th program, right? So recursion number 11. So this is nothing but what we have, sir. Okay. So anyway, tomorrow we will discuss rest of the things. Still some few more programs are there, like related mathematics. Some 3 to 4 examples are there. After that, we will start a string related programs using recursion, and we have towers of Hanayi problem, all these things. So there we will discuss. Okay. And I request 1 minute.